apparently I never uploaded this. This is old. Very short, very simple program. Why print a single space? That's just weird. I don't know why I had it print a single space there. But anyway, this just goes from latitude minus 116 degrees, also known as the Antarctic on the opposite meridian, to plus 116 degrees, which is the Arctic on the opposite meridian, via the equator on this meridian, 4 degrees at a time, which was just to keep the list short, and then it calculates the solar irradiance when the sun is over the Tropic of Capricorn, when it's over the equator, and when it's over the Tropic of Cancer. You'll notice the numbers, just where the mouse is, assuming the mouse cursor is showing, lines 20, 30 and 40, those numbers are not all the same. Those numbers are the perihelion, probably the semi-major axis, and the aphelion of the Earth's orbit. This means your results won't be quite the same. And the results you get, sorry, that was list, run. The results for the Southern Hemisphere in its summer, I know I call winter and summer around December and June. I should have called them December and June. I apologise. Plan a walk, I'm sorry. Anyway, the amount of solar irradiance you get on each line of latitude, which is down the left, sorry, yes, at each latitude down the left, in December solstice, well, approximately solstice. Oh, I did approximate to solstice and perihelion and June solstice and aphelion being the same time, which they're not. This is an approximation. But the results aren't quite symmetrical because the December solstice solar intensities on the left and the June solstice solar intensities on the right are at different distances from the sun. Where you get negative numbers, you can't have negative solar irradiance, right? Where it goes to negative around, funnily enough, around 66 degrees north, just weird that, approximately 23.5 degrees from the North Pole, it just goes to zero. The sun's below the horizon, even at noon, and you can't see it. This is assuming a point light source sun as well. Should point that out. So I'm going to get rid of those prints now that you've got the numbers on screen, and I'm going to replace them with something else. Actually, why is there a blank line up there? Mode 0 blanks the screen and puts the cursor at the top. 5, move 0, 0. 80, draw a line 2. Do hope it likes brackets on this. Do hope it doesn't require brackets for a move. Draw 2, latitude. It's only 232 and I got 1,280, so I can afford to go back times 4, can't I? So 640 plus latitude times 4, comma, we have a problem. Because I'm trying to do 3 lines at once, this would only do 1 line. Right. And I'm in the wrong mode for this. 0, mode 2, because it has colours and horrible resolution. 0, 0. 5 can disappear, can it? No, 5 can be changed to win in 10 equals 0. That's a control. Colon. Screw it. 7. Spring and autumn intensity equals 0. 9. Summer intensity. That says sun, not sun. Sum in 10 equals 0. How very north hemisphere centric of me. Right. 42 old wind intensity equals wind in 10 old spring intensity equals spring in 10. Let me just just keep the lengths consistent. Old summer intensity equals summer intensity. Then calculate the new ones. Then 82. Yeah, maybe there should be more than 4 lines in there. Colour. What do we want? Red, blue and green? Makes sense. Red. Move. I need an old latitude, don't I? Really need an old latitude. Yeah. So I can put that up there as line 2. Old latitude. We'll just start at minus 120. Move. Old latitude. 640 plus old latitude times 4 to old summer intensity. Let's do summer in red. Let's get out of sequence and do summer in red first. Draw green for spring, makes sense. It's just and blue for winter, unless you're in Australia. Or if this go horribly wrong. Due to a lack of brackets, which I'll have to come back and edit in. It's drawing a green line. You know, I know one thing I got very wrong. I know 2 things I got very wrong. Oh, Jesus. The print is still there. That should go. Also, it would be nice to have multiples of 10. There we go. Get rid of the print so it's not going to scroll the screen to hell. Apparently this is working, but I forgot something important. Yeah. Let's put brackets around it just in case it needs them. It's a 1024 pixel high screen and it doesn't draw the fractions of pixels, so I need that on each one. And interestingly, I seem to have missed out a line. Oh, right. Well, even before I fix that, the draw lines also need the multiplier. Otherwise you're going to get some really silly graphs. Just lots of lines going down at the bottom. It would actually have worked, but it it would have looked silly. And I need one more line, which is that. I know what's happened. I've typed in the correct thing with the wrong line number and overwritten the previous. Right. How's that? Looks good. See what happens. Missing close brackets. Oh. Interesting. Colon is new next command in the same line, which works. Might be a better way of formatting your code sometimes. Let's see what happens. Holy, that's well, interestingly, it is drawing the correct set of curves, but the left ends are all staying put. Why are the left ends staying put? Because I never updated old latitude. After drawing everything, 245, old latitude equals latitude. Now you should get curves. Oh yeah, there we go. So we have blue for December, green for March and September, red for June. You have the Tropic of Capricorn here at the peak of the blue, the equator at the peak of the green, and the Tropic of Cancer at the peak of the red. This is solar intensity over the course of a year. Ignore the little dot at 0, don't worry about it. Where these lines disappear through the bottom is where the centre of the sun, because I'm treating it as a point light source, disappears below the horizon, each side. This is the far side of Antarctica, this is the South Pole, this is the near side, well, far side of the Antarctic Circle, I should say. South Pole, near side of Antarctic Circle. Near side of Arctic Circle, North Pole, far side of Arctic Circle. And if the mouse isn't on the screen, none of that made any sense to you, so that was left to right. Over on the left, blue is far side, green is South Pole, red is near side of the Antarctic Circle. Over on the right, blue is near side, green is North Pole, red is far side of the Arctic Circle. Ta-da! And save state, sphere irradiance, graph.uef. Still less trouble than drawing it in GIMP. File load state. Flat Earth irradiance. It actually remembers what was on the screen. This is the equivalent of what I had before. Similar looking maths, or not. This is a whole lot of trigonometry. You've got the same latitude range, although on a flat Earth, 116 degrees south of the equator is open to quite a lot of very fierce debate among a bunch of idiots about whether it's snow 100 miles deep, or absolute nothingness, or bare rock covered in millions of miles of water, or they don't know. How the heck am I supposed to debunk the model if they can't tell me what it is? And then how far north of the sun you are? It's been a while since I wrote this. Spring north distance, winter sun angle, winter sun distance. winter intensity. It's the cosine of the angle because your ground surface is tilted times the hell is that? Oh, that's the peak I worked out before. That's just the maximum number divided by that's a weird way up. The square of the distance. Oh, the square of the distance. We're making assumptions about how high up the sun is, and that assumption isn't in there as a remark. That's awkward. Anyway, the same thing applies. 12. Win in 10 equals... Actually, I can get rid of that dot by making it minus 100. 14. Spring in 10 minus 100. Just get off the bottom of the screen so there isn't that dot. Summer intensity equals minus 100. Minus 100. 15. Old latitude equals minus 120. Not that it matters because it's going to be off screen. Somewhere way down off the bottom. I can't remember what I just did for the sphere one. Instead of printing it, I've just calculated the new figures. Yeah. 22 old winter intensity equals winter intensity. Old spring. Same deal. Summer, same deal. So then I have the old coordinates from which to draw to the new coordinates. Get rid of the print line. Oh. Let's use the same colours. .640 plus latitude times 4. Old latitude times 4. Not lat, old lat. 4, 2, old, we're in red, so summer intensity times 1000. Draw to and then pretty much the same thing, but spring, green, spring. That's what I did wrong last time, isn't it? I copied the number. That was why the spring one got overwritten with winter rather than getting a new line for winter. 150 needs to say this about spring. 2. Go to blue. Winter. Have I missed out a draw line? Very much missed out a draw line, haven't I? 151, I need to do the draw line. This is why you leave gaps. Spring intensity. Move 155. Winter intensity. Was this printing two sets of numbers or what? Why do I still have a print line there? Oh, latitude equals latitude. Is this all still there? I seem to have dropped my summer intensity calculation instead of my print line. That's inconvenient. Summer intensity is the cosine of the summer sun angle times, apparently we're doing the same number every time, so 964102500 divided by summer sun distance squared. It's actually more complicated on a flat Earth. Let's see what happens. Jesus. Okay, two things have gone wrong. At least four things have gone wrong. What the hell? One problem is that I haven't changed mode, so the colours are all coming out as white. Lovely high resolution. Those are all vertical lines. And then it just went nuts. Right. Yeah, first problem, put it in mode 2. Move to the old latitude, draw to the new latitude. And then old latitude equals new latitude. That should be going across. Let's see whether we're getting colours here. What? Oh. They put it in as 0, not as 10. Let's try again. This is absolutely sodding fabulous. This is... See, the red and the green have followed the curves. There is the correct curve at the bottom there, but the blue has gone off the roof. I know why they weren't showing before. Blue is an even number. Odd numbers turn up white and even numbers turn up black in mode 0. Right. Back into mode 0 so I can see what I'm doing. Couple of changes here. 640 divided by 4 is 160, so this can be 164. And this can be 160, which on a sphere is actually into the tropics on the far side. It's, you know, from the equator on one side, it's into the tropics on the other. It's nearly all the way around. I'm just doing that to fill more of the screen. Is my calculation incorrect? Is there something different about these lines? What the heck is 16215 anyway? It's tenths of a mile between the equator and a tropic. That's what it is. I'm working in tenths of a mile. Summer as in June. North, distance north from the subsolar point to the latitude in question. The 16215 less than its distance from the equator, assuming 69 miles per degree. The wind to sun angle is assuming the sun is 3,105 miles up. This is actually the sun angle from overhead, not its angle of elevation. All right. the distance is just the square root of the square of that altitude plus the square of how far away from it you are. And the intensity is the cosine of its angle from overhead. Yeah, that makes sense. So if it gets past 90 degrees, that's going to be a negative number, which makes sense because it'll be below the horizon at that point. Times the square of the height over the square of the distance. Inverse square law. Right, it's times this to get a number whose maximum value is 1, and it's divided by the square of the distance because inverse square law. Okay, I'm happy with that. I know where I got my numbers. Winter intensity went off the bloody roof, didn't it? Why? The December intensity. Am I just absolutely fat fingering this, or what? Look where my old winter intensity is, look where the latitude is. 60, I don't see the need for it anymore, so 60 can be my latitude loop. And 100 can disappear. Define your intensities as negative numbers so they're off screen. So the old latitude to be just before you start. Set up a latitude loop. Copy those to there. Calculate your distance north from the subsolar point. Calculate the angle from overhead. Calculate the straight line distance rather than the surface distance. Well, from the surface distance. Calculate the intensity. Plot your graph of intensities. This looks like it should work. Went off the roof, but now we get these curves. There's the blue at the top is the is the December intensity. It's just come past the Tropic of Capricorn. There's the equator on the spring and March and September intensity, and the red line is the June intensity, peaking on the Tropic of Cancer. And it stops. So it did work. Hooray. So we have blue for December, green for March and September, red for June. You have the Tropic of Capricorn here at the peak of the blue, the equator at the peak of the green, and the Tropic of Cancer at the peak of the red. Two things to note about this, two things that are very different. Three things that are very different. One is that those peaks are all the same height. Midsummer, it's not really midsummer, but sun directly overhead day, the equinox on the equator, would have exactly the same solar intensity as the sun passed directly overhead as sun directly overhead day, the December solstice on the Tropic of Capricorn, or sun directly overhead day, the June solstice on the Tropic of Cancer. So we have blue for December, green for March and September, red for June. You have the Tropic of Capricorn here at the peak of the blue, the equator at the peak of the green, and the Tropic of Cancer at the peak of the red. Whereas on the previous graph, the sphere one, because of the elliptical orbit, they're different. The Capricorn one's most intense. Also, the three peaks here, Penny again, we're inside Ingleborough. Don't we recognise them? Yes, the three peaks here are a lot sharper than they are on the, just looking at the very top part of the graph, they're a lot pointier, what narrower than they are on the sphere one. And the really big difference is something that the Wander and his comp, apparently, mentioned on YouTube, or rather, no, it wasn't him, it was Arctic Haze. It was Arctic Haze brought up in a YouTube comment the Wander and his comp asked for the maths. That's why I'm making this video. Down at the bottom, off to the sides, you see, apart from this blue line up the left side, don't worry about that. Left and right, we've got a point most of 24,000 miles south from the equator, still getting sunlight, and a point over on the right, somewhere most of 24,000 miles north of the equator, as in past the North Pole and almost to the equator on the other side, still getting sunlight. All the way across, there is no 24-hour darkness anywhere on this graph. When I put the other graph up, you'll be able to see no 24-hour darkness. You'll be able to see where the lines go off the bottom of that graph to show you where the Arctic and Antarctic circles are. So we have blue for December, green for March and September, red for June. You have the Tropic of Capricorn here at the peak of the blue, the equator at the peak of the green, and the Tropic of Cancer at the peak of the red. And where you should get 24-hour darkness. And it's just not there. The sun stays up. Actually, I could rejig this. File, save state, flat Earth irradiance, 2, save. Sun angle. Let's go 25. Winter sun angle equals. What should I call it? What should I call it? Let's call it 0.1. 35. Spring sun angle. 145. Summer sun. Habitually typing spaces between words, and of course we don't want them here. Those are variable names. Spring sun angle 0.1. Winter sun 0.1. Okay. The old winter angle equals the winter sun angle. That's what we're calculating, isn't it? Yes. The old spring angle equals spring sun angle. The old summer angle equals summer sun angle. Oh. 325. Oh, the latitude can stay the same, that's fine. And here, I want to go angle rather than intensity. But not necessarily times 1000, because it's pi over 2. Let's make it times 600. Arbitrary number, keeps on the screen. So that's sun angle times 600. Just to be clear, the BBC works in radians. If you want it in degrees, there's a command, deg thing. Right. The degree equivalent of 1 radian, 57.2958 degrees. If you want to convert back, there is a rad. How many radians is a right angle? It's 1.5708. 651. I could afford to multiply by 651, so 600 is a good number. That should now do almost the same thing, but it should plot a graph of the angle of the sun from overhead at each latitude rather than the solar intensity. Of course, the angle of the sun from overhead isn't like 0.1, it's... whoa, dude. Oh. It's not the angle of the sun from overhead, it's the angle of the sun north from overhead. That's ugly. That's legible. What's the command? It's been a while since I used this. Just try that. Actually, before I do this, yes, that is the command. Hurrah. So all I need to do is tell it to print the absolute value, the magnitude of each, to draw to a coordinate using the magnitude of the angle rather than using the actual angle itself. This is going to work just fine, honest governor. How the heck did I remember it was ABS? It's been how many years since I needed that? Anyway. Don't you just draw two vertical lines next to it in maths? Let's try doing it that way. See whether that works. Yay! Started off with the wrong number, that's why you have vertical lines on the left, and then you have December in blue, March and September in green, June in red, angle of the sun from overhead with latitude, meaning where they touch the bottom is the Tropic of Capricorn, the equator and the Tropic of Cancer. Notice that they're levelling out. I should have a coordinate line on there for something. Would never get below. What Arctic Haze said was that the angle would never get below something, which means those three lines are going to draw a white line across the screen at the end at one right angle away from overhead, i.e. at eye level, on the horizon. The sun half set, in the classic just half visible over the sea kind of scenario. Actually, you more often see almost the whole thing in a photograph of the sunset, but whatever. Sun at eye level. Hey, the horizon out at sea isn't at eye level. It's very close, you're standing on the beach. Anyway, let's also change the range of latitudes we draw. This is up to line 50. Line 100, where the heck is the loop? There's the loops at line 60. Let's go from minus 320 degrees, as in from... Still in step 4. Still in step 4. Oh, old latitude. Old latitude needs to be changed. It's 324. Right. And down here at the end, let's go times 2. It'd be nice to be able to edit this in Notepad sometimes. It'd be even nice to have an even cleverer editor that would let me just select an entire column of stuff and type down it without changing everything else. I kind of miss gold open square bracket and gold PF37 gold X, whatever it was. You know, just learn this sequence and then do it another 320 times. It's great for making the same change to each of 320 entries in a monster database for a video game, for example. Let's try that. That should draw the same coloured lines, blue for December, green for March and September, red for June, for a wider range of latitudes. A very silly range of latitudes, because it's starting 40 degrees north, going north through the Arctic, all the way down the far side of the Earth up to the equator, and then going up to the Arctic, all the way down the far side of the Earth, across the Antarctic, up to 40 degrees south. A total of 640 degrees around the Earth. Still got the silly thing on the left, that's fine, that's fine. That's what I was saying about the curves levelling off left and right, the same as they did with the sun intensity. On the sun intensity graph, they never get to 0. They just taper off to eternity both ways. And on the sun angle from overhead graph, there's Capricorn, the equator, Cancer. The vertical distance between red and blue is the range of positions in the sky of the sun over the course of a year. And they're levelling off. Where the hell's the white line? I specifically requested a white line. Where was my white line? Oh. Yeah. Helps if you draw it on the same scale. It's alright, I can cut this bit out. Significant thing, assuming this white line shows up this time, there we go. That white line is on the horizon. Down below that white line is closer to overhead. And down here at the bottom of the screen is exactly overhead.